So let's see both of these questions. This is from the redox reactions, right? Okay, so the question number 37. Just 37. Let's see what to do. So a sample of Fe2 SO4 thrice, right? We have Fe2 SO4 thrice and Fe sorry, FeC2 C2, right? Dissolved in dilute H2SO4. So that means it's acidic solution, and we are reducing it with a KMnO4. So MnO4 minus. Okay. So here you have Fe3 plus, SO4 2 minus, and you have Fe2 plus from here, Fe2 plus, C2O4 2 minus, right? So MnO4, this is acidic situation. So what will happen is MnO4 will become Mn2 plus, right? Then Fe3 plus won't undergo oxidation. This will not undergo oxidation. It will also not undergo oxidation because both Fe and sulfur are in their highest oxidation state. But Fe2 plus, this will undergo oxidation and this will undergo oxidation. So you'll get Fe3 plus plus CO2, correct? So Fe2 plus and C2O4 2 minus becomes CO2. Okay. So n factor of Fe2 plus is 1. C2O4 2 minus is, C plus 3 is becoming plus 4 and 2. So n factor is 2. N factor of MnO4 2 minus, you already know. In this case, it is 5. Okay. So keep this in mind, right? First, this is what happens. Then, okay. Then what happens is, so this Fe3 plus remains in the solution, correct? So this Fe3 plus is from Fe2 plus and also Fe3 plus, both. So next we are reducing with zinc. So you have Fe3 plus CO2. You need to understand CO2 will be gas, obviously, so it will escape, right? So that will not further undergo reduction. So if we do reduction with zinc, it is only Fe3 plus. So you have a SO4 2 minus, but SO4 2 minus will not undergo reduction by zinc. So if you use zinc, what will happen is Fe3 plus will become, Fe3 plus will undergo reduction to become Fe2 plus. Okay. So this process, N factor is actually 1. Zinc becomes Zn2 plus, correct? So N factor is 2. But anyway, we don't need to worry about that. We don't need to worry about what happens, sir. We just need to understand this Fe3 plus will become Fe2 plus. Okay. Now, let's see. We have, so the first case, oxidation of mixture using KMnO4, correct? Oxidation of mixture using KMnO4. So in that case, suppose we have some concentration for Fe2 SO4 thrice and FeC2O4, right? So we know equivalence of Fe, so equivalence of Fe2 C2 FeC2O4, right? So n factor is 1 here for FeC2O4. This n factor is 2. This n factor is 1. So total n factor is actually 3, correct? So equivalent of FeC2O4 is actually equal to equivalent of MnO4 minus. Correct? So you have 3 multiplied by, right? Yeah. So let's write the KMnO4 part first, right? You have n by 16 multiplied by 40 divided by 1000 should be equal to equivalent of FeC2. Correct? So n by 16 meaning 1 by 16. So still cut, right? 4. So it will be 1 by 400 equivalents. Or if you multiply it by 1000 for milli equivalent, you will get it as 1000 by 400. So 10 by 4, 2.5 milli equivalents. Okay, let this be here. Now let's see what will happen. So you have, suppose you have equivalence of this is 2.5, right? Okay. So next time you have Fe2 plus from Fe2 plus from both Fe2SO4 thrice and Fe2 FeC2O4. Correct? Right? Oxidized. Okay. So you have both. When we do the reduction part, we will get Fe2 plus from reduction of Fe3 plus in Fe2SO4 thrice and reduction of the oxidized part of FeC2O4. Okay. So this we already know what is equivalence. Equivalence is 2.5 milli equivalent, right? This we don't know. So anyway, again, we are doing with the KMnO4, right? The same KMnO4. Okay. Same KMnO4, 60 milli. So we know 1 by, so I can write equivalent of KMnO4 should be equal to 2.5 milli equivalent, right? Plus equivalent of Fe2SO4 thrice. Okay. So what is the equivalent of? So you get 60 multiplied by, you can find it in milli equivalent, 60 multiplied by 1 by 60. Correct? It's the same normality. So when you cut this, if you can cut 4, you get 15. 4. So 15 by 4, you will get 7.5, 3.75 milli equivalent is equal to 2.5 milli equivalent plus equivalent of Fe2 SO4 thrice. Okay. So equivalent of Fe2 SO4 thrice will be 1.25 milli equivalent, which implies ratio of you see they're asking equivalent of Fe2 SO4 SO4 thrice divided by equivalent of FeC2O4. It is 1.25 milli equivalent divided by 2.5 milli equivalent. So it will come as 2. Okay. So this is how you do the question number 37.